ScanaQuad logic analyzers are tiny but powerful tools that let you analyze logic signals. What makes ScanaQuad even better is its ability to generate digital patterns. Those patterns can be used to test your equipment without having to build costly prototypes. In this tutorial, I'm going to show you how to get the best out of ScanaQuad's pattern generator. I'll be using a ScanaQuad SQ200, but the same is applicable with other ScanaQuad models. ScanaQuad can generate digital signal using 3 different modes: generate, loop, generate once, mixed mode. Mixed mode lets you generate and capture signals simultaneously. Before we can test those modes and generate some signals, first we need to build the digital patterns to be generated. There are currently 2 methods to do that. The first is a simple signal builder wizard that allows you to generate a periodic square wave and change its frequency and duty cycle. I'll let you play with this wizard and test it on your own. The second method is the script-based signal builder. That's what I'm going to concentrate on because it's quite a powerful tool. Now, let's start with a practical example. Imagine we want to generate a digital signal that looks like that. I'll guide you step by step to show you how easy it can be done with ScanaStudio. Start by creating a new ScanaQuad workspace and click Open Script Signal Builder. This is simply a JavaScript interpreter. You can save your script at any time or open existing ones. You can even use ready-made templates, but we won't handle the templates in this tutorial. You don't need to be a professional JavaScript programmer to use the signal building features. However, it will help if you have some general programming experience in similar languages like C or C++. Let's write some code that adds 100 samples having a logic low level, followed by 20 samples having a logic high level. Click Apply to check the result. As you can see, the first low-level pulse is here, but we can't find the high-level pulse. That's normal. ScanaStudio will fill the entire generator duration with the last logic level. Let's go back to Signal Generator and correct this by adding 1 low-level sample at the end. Here we are. We have built a first simple pattern with a logic low level and logic high level. Now let's get this to the next stage. Instead of generating a pulse having a duration of 100 samples, what if we want to generate a pulse whose duration is expressed in microseconds? ScanaStudio has some convenient functions that lets you do that. Let's add this piece of code. The function getSampleRate is already implemented in ScanaStudio and returns the sampling rate expressed in Hertz. I've created a helper function that converts time to number of samples. I'll let you figure out the simple math behind this line of code. Now let's see how this looks like on the waveforms. Timings are correct. We do have a 100 microseconds low-level pulse followed by a 20 microseconds high-level pulse. Before generating this signal on the probes, it's a good habit to verify if the desired channel is correctly configured. Click on Configure Inputs/Outputs buttons and select Channel 1. You'll notice that ScanaStudio have already configured it as an output. Depending on your application, you may configure it as open drain output or add a pull-up resistor. Finally, don't forget to verify that the target voltage matches your needs. It will be set to 3.3 volts by default. For this example, we'll keep all the default values. Now let's generate this sequence in a loop. I've connected an oscilloscope to take a loop at the output in real time. Let's hit the Start button. ScanaStudio will upload the pattern to the ScanaQuad device, then generation will start. As you can see on the scope, our signal is repeating periodically. Now you may wonder, how do you configure the periodicity of this signal? For that, you need to go back to ScanaStudio Workspace. Zoom out to fit the whole waveform in the screen. You'll notice there's a red line at the bottom of channel 1. This line represents the total generator period. Move the cursor above it, and a pop-up message should tell you the exact period. To change this, click on the device memory. Change the generator period with the slider, or simply type the value you want in the test box. Let's hit the Start button again and check the difference on the oscilloscope. As expected, the period is now 10 milliseconds. Applications are endless and only limited by your imagination. If you need any help with some practical case, don't hesitate to contact us or post on the forum. We'll be glad to assist you. Thank you for watching.